हेलो माय डियर मैकेनिकल स्टूडेंट्स, हाउ आर यू ऑल? व्हाट्सअप, कैसे हैं सब लोग? अपने किमेन आचेन. This is Chandrasekhar welcoming you all to the India's largest, the best and your favorite live learning platform, that is BYJU'S Exam Prep. So those who are watching me live, please respond through the comment section if I am audible and visible to everyone so that we can start the session at the earliest. So I welcome you all to the beautiful session or beautiful series, which is GATE Rankers Monsoon series, that is pre-course, which is running on BYJU'S YouTube channel. And today and tomorrow we will be discussing the questions from the industrial engineering subject. So the two sessions will be there for industrial engineering. As you all know, the monsoon series is already going on. So today we will be having the question practice from the linear programming problem, very important topic for GATE 2023 examination, and queuing model. These are two very important topics. Most of the times you will find either the questions from LPP or queuing model or both. So shall we start? Please do let me know through the comment section if my audio and video quality are all fine. Those who are attending the class for the first time, those who are coming here for the first time, this is my quick introduction. My name is Chandrasekhar. As I said, I am a mechanical engineering graduate from IIT Delhi and also engineering services examination qualified. Worked in sale for a couple of years and also worked in a private consulting firm for more than 2 years. So my total industry experience is more than 4 years, and from last 10 plus years I am completely into teaching, guiding the students, mechanical engineering students, for various competitive examinations like GATE, PSU and engineering services. I am quite comfortable in these many subjects of mechanical engineering, fluid mechanics, heat transfer, thermal and industrial engineering. If you want to discuss any doubt regarding any of these topics or regarding your career, you can always join me on the Telegram. My Telegram group is Mechanical by Chandrasekhar. Those who are not part of my Telegram group, I would strongly request everyone to be part of my Telegram group so that you will get all the updates, notifications of the free sessions which we bring from time to time for the students' benefit. Moreover, I will be giving the questions for practice, and the study notes will also be provided to you on my Telegram group. That is Mechanical by Chandrasekhar. You can search me with this name on the Telegram. So many students are already part of the Telegram group, so they discuss, they share their knowledge, they discuss the questions, they discuss the doubts, and you can also get benefited from that. Yes, I was talking about the GATE Ranker Monsoon series, which is important, beneficial for all the GATE 2023 aspirants, and that is completely free, which is running on BYJU'S YouTube channel. So to get to be part of this GATE Ranker Monsoon series or Monsoon course, you should subscribe our BYJU'S YouTube channel so that you will be getting the notifications of the classes every day. So the timing is every day from 6 to 7 p.m. Right? Most of the students are already aware about that. So here we are having the beautiful questions, bring the beautiful questions through which we are going to learn the fundamentals, we are going to revise the related concepts. This is how it is going to work. If you want to be part of our paid courses, there are paid courses also running on BYJU'S platform. If you want to be part of the paid courses which are more organized, structured, where we discuss all the theory along with the numerical practice, we give you the study notes, so it is more organized, structured manner. If you are interested to be part of our paid course, then there will be 90% scholarship on our paid course you can avail. For that you need to register, which is completely free, and there will be test on 10th of July at 11 a.m. All right. So this is very, very important information for those who are thinking of preparing for GATE 2023 in an organized, structured manner, where we take care of everything which is required for cracking GATE examination. You just need to work hard. Rest of the or all of the things are taken care by us. All right, so let us start discussing the question. Are you guys writing anything in the comment section? I am not able to see your comments. Please do write. Those who are watching me live, please do write in the comment section. Please mark your presence by writing in the comment box. So there is the first question, which is from the queuing model. A dedicated machine received jobs at this is the type of question you can expect in GATE 2023 exam. In queuing model, most of the questions will be formula based, directly formula based. There are 5 to 6 or more, maximum 10 formula which you need to memorize for getting the answer, correct answer for question from the queuing model. So a dedicated machine receives jobs at the rate of 20 per hour. The arrival rate, lambda, is equal to 20 jobs per hour. That is lambda. That is called as arrival rate. And the processing rate or the departure rate or the service rate of the machine is 30 jobs per hour. So that is denoted by mu. That is 30 jobs per hour. Processing rate. Assume the following: inter-arrival time, the time between the successive arrivals, and processing time jobs follow exponential distribution. That is called as Markovian. Queue discipline is FCFS, first come first serve. Queue capacity and job population are infinite. For how much time on an average does a job have to wait before it gets loaded on the machine? What do we need to find out? First of all, you should mention all the given parameters. These are the given parameters. Now, what do we need to find out? What do we need to find out? The waiting time for the job in the queue before it gets loaded on the machine, means the waiting time in the queue. That is the question, waiting time. हाँ भाव्या, सिर्फ क्वेश्चन है. Good evening Sandeep, welcome to the session. The monsoon series is all about practicing the questions and along with the numericals, because GATE is all about the numericals. So along with the numericals, through the numericals, we are going to discuss the related theory. That is how it is going to work. So what is the waiting time in the queue? Can anybody let me know the answer to the question? Please do write your answer in the comment section. So how to find out waiting time in queue? Do you know that? Do you guys know that LS is equal to lambda times of WS? The system length is equal to lambda times the waiting time in the system. LQ, the queue length is equal to lambda times of WQ, isn't it? These are known as, what do we call them? They are known as little formula. So from the Little's formula, we can write WQ is equal to LQ by lambda. That is equation number 1. LQ by lambda. Hi Shubham, good evening, welcome. LQ by lambda. You can easily develop the formula for WQ in terms of lambda, mu and utilization factor. Do you know what is lambda by mu? That is denoted by rho, which is called as utilization factor. This is called as utilization. Lambda by rho is called as, lambda by mu is called as utilization factor. So WQ is equal to LQ by lambda. How to find out LQ? Another expression, if we talk about another important expression, is waiting time in the system is equal to waiting time in the queue plus service time. 1 by mu is called as service time, the time for servicing a job. So if we multiply with lambda, so we can say lambda into WS is equal to lambda into WQ is plus lambda by mu. So lambda into WS we have already written, that is called as lambda by WS. lambda into ws is equal to ls, lambda into wq is equal to lq, plus lambda by mu is rho. So from here we can say lq is equal to ls minus rho. lq is equal to ls minus rho. So wq is equal to ls minus rho upon lambda. How to find out ls? What is ls? ls is equal to summation of npn from n is equal to 0 to infinite. If you solve this, then ls will come out to be rho upon 1 minus rho. If we put the value of ls here, if you put the value of ls here, or if you put the value of ls here, then lq will come out to be rho square upon 1 minus rho. That is the length of the q. And if you put the value of lq here, if you put the value of lq is equal to rho square upon 1 minus rho into 1 by lambda. This will give you the answer. That is the average waiting time in the queue. That will give you the answer. Average waiting time in the queue. Can you solve it? Can you solve it? 2 by 3 is rho 2 by 3 square upon 1 minus 2 by 3 into 1 by 20. That is in hour, and if you want to convert it into second or minute, the options are in minute. We need to multiply by 60. So it is 4 by 9 into 20 into 3. Isn't it? That will. So 4 minutes will be the answer. The answer will be 4 minutes. Isn't it? Option A is the correct answer. Yes, Shubham had given the correct answer. I could have used the formula directly, but you need to understand how you can develop the formula from the basic observation. Little's formula is very, very important. Other than that, this expression is very important. From here, you can easily develop the formula. Next question on the screen, question number 2. Again from the queuing model. As per Kendall notation in MGC queuing system, the number of arrivals in a fixed time follows. M stands for Markovian. The management scientist had decided or had given that the queuing model follows the Markovian distribution, where the arrival distribution is Poisson and service rate or service time follows exponent. That is called as Markovian exponent. It is about the number of arrivals in a fixed time. That is arrival rate. Arrival rate will follow. What is the answer to the question? Option C. C will be the correct answer. The number of arrivals will follow Poisson distribution, but the service rate will follow exponential distribution according to management scientists. Question number 3 on the screen. Next question. Can you get the answer to this question? A constraint. The question is from LPP. This question is from linear programming problem. A constraint that does not form a unique boundary of feasible solution space is called. Now, I am waiting for your answer for this question. Question number 3. I want everyone to give me the answer. Hi Shubham. Good, good, good. What about others? There are 3 types of constraint. One is known as redundant. What is redundant constraint? When the constraint is not part of feasible boundary. It is not part of feasible boundary or feasible region, which is not part of feasible region or feasible boundary. And others are, the second category is called as non-redundant. Non-redundant, which is a part of feasible region. So non-redundant can be further divided into 2 types. One is binding constraint. Non-redundant means part of feasible region, and binding constraint is when the optimum point lies on it. When optimum point lies on it. That is called as binding constraint, and another is non-binding. What is non-binding? When optimum point, it is a part of visible region, but optimum point does not lie on it. Optimum point does not lie on it. Are you getting it? So there are two types of constraints. One is redundant, which is not a part of the feasible region or feasible boundary. The second one is non-redundant, which is a part of feasible region or feasible boundary. And the non-redundant constraints can be further divided as binding constraint or non-binding. When the optimum point lies on it, then it is called as binding constraint. And when the optimum point is not lying on it, then it is called as non-binding constraint. This is how the constraints are classified as. The question is a constraint that does not form a unique boundary of feasible solution space. It means when the constraint is not part of the boundary or the feasible boundary or feasible region, that is known as redundant. Option D is the right answer. That is called as. Do you agree? Do you know that LPP model always have all LPP model always have a convex boundary? Because of linear nature, LPP model is always having a convex boundary like this. This is the feasible region. It will always form a convex boundary like this. It cannot be concave. The feasible region cannot be concave. The feasible region cannot be concave. It can only be convex. The feasible region is always convex boundary for LPP problem, isn't it? The answer to the question is option D. Can we move further? Question number 4 on the screen. Now you need to solve question number 4. Whenever the decision variables are 2, there are 2 decision variables. There are 2 methods to solve LPP model. One is the graphical method. When the decision variables are 2, then you can go for graphical method to solve the LPP. And when the decision variables are more than 2, then you should go for simplex method. Because there are 2 decision variables, x1 and x2, so we can go with the graphical method. The question is, it is about the maximization of z objective function 5x1 plus 3x2 subject to the following constraints. x1 minus x2 is less than 2, x1 plus x2 is greater than 3, and x1 and x greater than 0. The above LPP has. You don't have to solve it. You need to find out whether the LPP is having which solution. Can you solve it? So the question is maximization of objective function 5x1 plus 3x2. Subject to the constraints are x1 minus x2 less than 2, less than equal to 2, x1 plus x2 greater than equal to 3, and x1 and x2 are greater. If we draw the graphical method, on x-axis one decision variable, that is x1, on another it is x2. If we draw the graph 1, 5, let us say 1, 5. If we show this constraint x1 and x2 less than 2, if we put x2 is equal to 0, x1 will become 2, x1 will become 2, this will be the point. And if we put x1 is equal to 0, x2 is equal to minus 2, that is minus 1, this is minus 2. This is the another point. So the first constraint is equation is this line. This is the first constraint. Now you can check which is the region. So we can say because 0, 0 is satisfying this inequality, it means the 0, 0 lies in the region which is satisfied this inequality. This will be, we can say, This will be the region. Will be the region. And if we talk about the second, x1 plus x3, the second one is x1 plus x2 is greater than 3. So if we put x1 is equal to 0, x2 is 3. This is the point. If we put x2 is equal to 0, x1 is equal to x1 is equal to 0, x2 will be 3. This is the line representing the constraint equation. This is 2. Now, if we put 0, 0 greater than 3 is not satisfied. So the point is not lying in the region satisfied this inequality. So this is the region. The common region is the feasible region. The common region will be the feasible region. So the feasible region will be this. This is the feasible. Now it is about the maximization. Because it is about the maximization of objective function 5x1 plus 3x2. If we take for z is equal to 15, so we can say 15 is equal to 5x1 plus 3x2. If we put x1 is equal to 0, then x2 will be equal to 5. x2 will be 5. And if we put x2 is equal to 0, x1 will be 3. So this is the objective function line. This will be the objective function line for z is equal to 50. If we move z in right hand side, z increases. If we move z in right hand side, it will increase. So for maximization problem, that is unbounded, because we cannot, there is a solution, but we cannot find out the solution using these constraints. It is called as unbounded. Isn't it unbounded? The solution is unbounded. But if it would have been, so option D is the correct answer. But if it would have been a minimization problem, listen very carefully. If the question would have been for minimization problem, then this would have been the point, unique solution for minimum value of z. For minimization problem, this point would have represented the minimum value of z, isn't it? For minimization problem, if instead of the objective function, if instead of maximization, if it would have been minimization, then the correct answer would have been option B. Then the correct answer would have been option B. For maximization, the correct answer is option B. Is this clear to everyone? Ready for the next question? Can you solve the next one on your own? The next question is from the queuing model. Customer arrive at A. Yes, yes, no. बताइए, कोई डाउट है तो you can ask through the comment section. हमें find out करना होगा. जैसे what we need to do is we need to draw the z objective function. Look, चलिए आपने पूछ लिया तो बता देता हूं. Are you able to develop the feasible region? Are you able to develop the feasible region? The steps for using the graphical method is each and every constraint can be written in the form of equation. We can write it as x1 minus x2 is equal to 2. For that, we can draw the line. So line 1 represents the constraint equation 1 and line 2 represents the constraint equation 2. Now, which is the region satisfied by the inequality? We can put any point 0, 0. 0, 0 is most convenient to put. If we put x1 as 0, x2 as 0, so the origin 0, 0 is less than 2. So the point is lying in the region satisfied by the constraint inequality for 1. Similarly, if we put 0, 0 in constraint inequality 2, then 0 greater than 3 is not satisfied. That is not true. So the reason satisfied by the constraint inequality is the region which is not containing 0, 0. The common region of all the constraint will be the feasible region. Now you can take z, any value of z. Z is equal to 15 I have taken. So if we put x1 is equal to, here x1 is equal to 0, then x2 will be equal to 15 by 3, that is equal to 5. And if we put x2 is equal to 0, we put x2 is equal to 0, then x1 will be equal to 15 by 5, that is equal to 3. So 0, 5 and 3, 0 will be the equation for objective function which is having the value 15. That is the equation for the objective function. This is our objective function. This is the objective function. whose value is 15. Now, if we take z is equal to 30, for z is equal to 30, means increasing z. For z is equal to 30, if we put x is equal to 0, x1 is equal to 0, what will be the value? So x1 is equal to 0, x2 will become 10, x2 will become 10, 30 by 3, 30 by 3. And for x2 as 0, it will become, x1 will become 30 by 5, that is 6. So it will be 0, 10 and 6, 0. So 0, 10 and 6, 0. That will be the parallel line. This represents z is equal to 30. This represents z is equal to 30. One line represents z is equal to 15. Another parallel line represents z is equal to 30. So we can say in this direction z is increasing. The minimum, if you move in the backward direction, z decreases. So the last point, if you roll the z function towards left, if we move the z function line towards left, then the last point on the feasible region will be the minimum. The last point on the feasible region, this will be the last point on the feasible region. This will give you the minimum value of z. The point is 0, 3. The point is 0, 3. That will give you the minimum value of z. That will give you the minimum value of z. What is the minimum value of z? If you put x1 is equal to 0, x2 is equal to 3. This point is 0, 3. So it will be 9. Z minimum will be 9, isn't it? X1 is equal to 0, x2 is equal to 3. X1 is equal to 0, x2 is equal to 3. So 9 will be the minimum value. Have you understood it? Just know that was for you only. All right, the next question on your screen. Customer arrives. The next question, please try to solve the question. Customer arrive at a service counter named by a single person according to a Poisson distribution with a mean arrival rate of 30 per hour. Lambda is 30 customers per hour. 1 by lambda will be inter-arrival time. 1 by lambda will be inter-arrival time. Arrival rate is given at 30. The time required to serve a customer follows an exponential distribution with a mean of 100 seconds. What is that? That is 1 by mu, service time. 1 by mu is service time. That is given as 100 seconds. If you convert it into R, that means 100 multiplied by 36. If you want to convert it into R, 100 by 3600 R. So mu will be equal to 3600 by 100 customers per hour. Customers. That is mu. 1 by mu is service time. That is given as service time. And 1 by lambda is inter-arrival time. Time between the successive arrivals. Inter-arrival time. Sometimes time may be given, sometimes rate may be given. That is 36. So mu is equal to 36, lambda is 30. So rho will be equal to lambda by mu. The utilization factor is lambda by mu, that is 30 by, that is 5 by 6. That is rho. Now the question is the average waiting time in hours of the customer in the system. Waiting time in the system. So WS need to be calculated. You need to calculate WS. How to calculate WS? Can we say from the Little's formula, LS is equal to lambda into WS. So WS will be LS by lambda, and LS I have already told you 1 by lambda. LS is equal to rho upon 1 minus rho. If you put the values, you will get the answer in R. You will get 1 by 6. Yes, service rate is 36. Very nice. That will give you 1 by 6 R. Waiting time in the system is 1 by 6 R. And 1 by 6 means 0.166. Option B is the correct answer. The next one is very, very beautiful question. The next question is very beautiful, very important. Consider the following linear programming problem: maximization, Subject to these constraints, apart from the non-negativity criteria, the dual problem for the given linear programming problem consists of, what will be the correct answer? If it is the maximization problem, its dual will be minimization. The dual will be minimization problem. And the constraints will have, for minimization, the constraints will have greater than sign. The constraints will have greater than equal to sign. So it is about the constraints. So the constraints will not have less than sign, because the dual will be minimization problem. So the constraints will have greater than sign. All the constraints will have greater than sign. A and C cannot be true. It is either B or D. Can you convert it into dual? Can you make the dual for it? That is the first part of the question. Can you convert this primal into dual? The question is, maximization of Z is equal to 3x1 plus 5x2 plus 8x3. Subject to, first of all, convert this into equation. So x1 plus 5x2 plus x4 is equal to 10, and x3 plus x5 is equal to 20. That is how we can convert it into equation. First convert it into equation. This will be 0x4 plus 0x5. This is how. Once you convert it into equation, then this is the equation. These are the slack variables to make it the constraint into equation. So then convert it into matrix, then matrix form. How to convert it into matrix form? Maximum Z is equal to, you can say 3, 5, 8, 0, 0. Then x1, x2, x3, x4, x5. Subject to, if you write constraints, x1, coefficient of x1 is 1, coefficient of x2 is 5, coefficient of x3 is 0, coefficient of x4 is 1, and x5 is equal to 0. Similarly, that is the first constraint. Then the second constraint, coefficient of x1 0, x2 0, x3 1, x4 0, x5 1. Then x1, x2, there are 5 variables, is equal to, then you can write 10, 10 and 20. So this is how you can convert it into matrix form. Once you convert it into matrix form, then you should develop the dual. How to develop the dual? For every constraint, assign a dual variable, that is y1. For another constraint, assign the another dual variable, that is y. y1 and y2 will be the dual variable. y1 and y2. So because the primal is a maximization problem, the dual will be the minimization problem. Minimum of w, let us say, is equal to, what we need to do is, the constraints right hand side will be the objective function. That is 10, 20, that is y1. This is the objective function. And subject to, because it is a minimization problem, then we will take the transpose of this matrix. We will take the transpose. So it will be 1, 5, 0, 1, 0. Then it will be 0, 0, 1, 0, 1 into y1 comma y2, greater than, it will be greater, because it is a minimization problem, it will be greater than sign. and the objective function matrix will be the right hand side for the constraint. What is that? That will be 3580. This is the dual. If we want to write in terms of LPP, then it will be minimization of W, that is 10y1 plus 20y2, subject to the constraints are y1 greater than 3. The second is y1 greater than 5. The third one is y2 greater than 8, and then y1 greater than 0, y2 greater than. There are three constraints. In dual there are three constraints, but if you see this constraint, y1 is greater than 3 and 5y1 is greater than 5. So y1 is greater than 1. One is y1 greater than 3, another is y1 greater than 1. Out of them we can say y1 greater than 1 will be a single constraint. So this is one constraint and this is the two constraint. There are two constraints with greater than sign. There will be two constraints with greater than sign. Option B is the correct answer. Shubham, because there are three decision variables in the equation, so we cannot use graphical method. Graphical method is having the limitation that it can be used only when the decision variables are only two. So to reduce the decision variables, we use the dual method. We convert the primal into dual, which reduces the number of decision variables. So because the total number of decision variables is 3, and if you see the dual of it, then the total decision variables are 2. These are the decision variables. So we can easily use the graphical method. The answer to this question will be option B. It will not be option B. Yes, if it becomes 2, if we can convert the decision variable into 2, then the graphical method can be used, because graphical method is more simple to use. Is this clear? I hope you guys know how to convert the primal problem into dual problem. The first step is to make it equation by introducing some more variables like x4 and x5. Make the LPP model into equation form, then write in matrix form, and then you can convert it into dual. The first step for dual is, if the primal is maximization problem, the dual will be minimization problem. One thing. The second thing is, for all the primal constraints, corresponding to all the primal constraints, you should assign a dual variable. y1, y2 are the dual variables. Now, the objective function, how the objective function will be written for dual? It will be minimization of W. Then this matrix will be replaced by this matrix in dual. This will be replaced by this matrix in. So it will be minimization of W, 10, 20, y1 and y2, isn't it? And then this matrix you will take transpose. Constraint matrix you should take transpose. The rows will be converted into column or vice versa. So, and then there will be decision variable and equal to, then this matrix will be replaced by this. That is how dual. And because the dual is a minimization problem, the sign will be greater than. Have you understood it? In primal, this was the matrix over objective function, and this was the matrix over the constraint right hand side. But they have changed their relative position. They have changed their position. So because they are looking like three constraints, but two constraints can be converted into single constraint. So our problem is, now if I write the problem, the next part of the question, what is the value of objective function after solving the dual problem? What is the minimum value of W after solving the dual? That is interrelated question. So our dual problem is minimization of W, or let me write here, our dual will be minimization of W, that is equal to 10y1 plus 10y1 plus 20y2. Subject to the constraints are y1 greater than 1 and y2 greater than 8 and y1 y2 greater than. If we draw here, it will be y1 on x-axis, y2 on y-axis. So y1 greater than 1, this is 1. y1 greater than 1 means, and y2 greater than 8. Let us say this is y2 greater than 8. Very simple to analyze. This is the y2 and 8 is this. The common region is this. This is the feasible region. This is the feasible region. And this is the minimum point. This will give the minimize. This will give you. For minimum point, y1 is equal to 1 and y2 is equal to 8. That will give you minimum value of w. If you put y1 is equal to 1, so w is equal to, w minimum is equal to 10 into 1 plus 20 into 8 will give you the answer, that is 10 plus 160, that is 170 will be the answer. 170 will be the answer to this question. Option B is the correct. Is this clear to everyone? This is how, by using the dual, we can solve it by graphical method. The primal cannot be solved by using the graphical method. The primal can only be solved by using the simplex method. The next question, question number 8 on your screen. Question number 8. Which one of the following is the correct statement? In the standard form of a linear programming problem, all the constraints are of less than equal to type or greater than equal to type, or in the form of equation. Some constraints are of less than equal to or type, and some of them are greater than equal to type. The standard form of a LPP, the constraints can have greater than equal to or less than equal to sign. Isn't it? So it is not a rule that it should always be less than or it should always be greater than. So option D is the correct answer. Some constraints are of less than equal to sign. When there are less than equal to sign, we use the slack variables, and when there are greater than, we use the surplus variable. Option D is the correct answer. The next question, a feasible solution to the linear programming problem should satisfy the problem constraint, optimize the objective function. The feasible solution does not optimize the objective function. The optimum point only optimize the objective function. Satisfy the problem constraints and non-negativity restrictions. Satisfy the non-negativity restriction. What is non-negative restriction? All the decision variables are non-negative. That is non-negative restriction. So, because if we use the graphical method, the graph should be drawn in first quadrant. It means it is satisfying x1 greater than 0, x2 greater than 0. The feasible reason will be in first quadrant only. It must satisfy the non-negativity restriction as well as it must satisfy the problem constraint. Option C is more appropriate. Option C, the feasible solution. And the corner points are known as basic feasible solution. The corner points will become the basic feasible solution, right? So the feasible solution is satisfying the problem constraints as well as the non-negativity restrictions. So option C is more appropriate than A or D separately. If it would have been MSQ, then A and D both would have been correct. Question number 10 on the screen. In a linear programming problem, which one of the following is correct for graphical method? For the graphical method, a point in the feasible region is not a solution to the problem. All the points in the feasible region, all the points in feasible region are solution to the problem. Each and every point in the feasible region is a solution. That is why we get infinite solution for a particular problem. A is not correct. One of the corner point of the feasible region is not the optimum solution. Corner points will represent all the corner points will become the basic feasible solution. They are known as basic feasible solution. The corner points will represent the basic feasible. The entire common region will be the feasible region or feasible solution, and the corner points will become the basic feasible solution. And out of these corner points, one will be the optimum solution. The optimum point out of these corner points will be the optimum solution. Can we say B is also incorrect? One of the corner points of the feasible region is not the optimum solution. Out of these corner points, there will be one optimum point. Any point in the positive quadrant does not satisfy the non-negative constraint. All the points in the positive quadrant satisfy the non-negative constraint. X1, X2. B is also incorrect. The lines corresponding to different value of objective function are parallel. Did you see? Z is equal to 15 and Z is equal to 30 are parallel to each other because they are having same slope. It is only the value of Z which is changing, but the slope of the objective function is still the same. If the slope is same, then they are parallel. What is the slope? That is, the slope is given by, what is the slope? Slope can be calculated by, how to calculate the slope? The slope is calculated by minus coefficient of x1 divided by coefficient of x2. That is the slope of a curve. Because the slope is same, they are parallel to each other. All the value of objective function will have the parallel. Yes, option D is the correct answer. Yes, Shubham. Option D is the correct one. Have you understood each and every option here? Next question, question number 11 on your screen. Question number 11 on the screen. In case of solution of linear programming problem using the graphical method, again, if the constraint line of one of the non-redundant constraints is parallel to the objective function, it means having the same slope. If a constraint line is same slope of non-redundant constraint, redundant constraint has nothing to do with it. We are talking about non-redundant. If the slope of non-redundant constraint is equal to the slope of objective function, and what is the meaning of that? That means it will have alternate solution, multiple number of optimum solution. Then it means it will have multiple number of optimum solution, isn't it? The slope, then it will give alternate solution. Multiple solutions will be provided by such LPP problem. When do we have infeasible solution? When there is no common region. No common region. When do we have degenerate solution? When optimum point is overdetermined. When the optimum point is overdetermined, then we have degenerate. What is the meaning of degenerate? In simplex method, degeneracy means the next iteration will not bring the solution closer to the optimum. The next iteration will not make the solution more optimum. So it is an extra step. Degeneration. Look how. Look, if the graph is like this, this is, let us say, optimum point. This is the optimum point. This is the common region. This is the optimum point. But there is one more constraint which is passing through the same point like this. This is 1, this is 2. There are 2 constraints. So this point is the intersection of 3 lines, isn't it? This point is intersection of 3 lines. One is y-axis, another is constraint 1, another is constraint 2. So the point is actually a intersection of two lines. A point can be defined as the intersection of 2 lines, but it is an intersection point of 3 lines. So that is how we can say degeneracy. We can find out the optimum solution. There is no problem in getting the optimum solution. We can find out the optimum solution. but there is a degeneration. Is this clear, Shubham? What is unbounded solution? We have already discussed. But unbounded solution when the feasible region is unbounded. Feasible region is unbounded. It means we can find out there is a solution, but we cannot determine using the constraints. But I had told you, if it is a minimization problem, even if the feasible region is unbounded, then also we can get the unique solution. That all depends on the objective function. If the objective function is minimization, then we can get the unique solution. But if the objective function is maximization, then it can be unbounded solution. I hope it is clear. These are the various types. Next question on the screen. Consider the following statements regarding the characteristic of standard form of a LPP. For standard form, there are two rules for simplex to get started. All the variables, all the decision variables should be non-negative, and all the constraints should be converted into equation with no negative RHS. Must be equations using slack or surplus variable. Using slack variable or surplus variable with non-negative RHS. Right hand side. If it is negative RHS, then you should multiply the whole equation with -1. Then it will become no negative RHS. Now, all the constraints are expressed in the form of equation. That is correct. Using slack or surplus variable. One is correct. The right hand side of each constraint equation is non-negative. Yes, I have already told you that is also true. All the decision variables are non-negative. That is also true. So the correct answer for this question is option A. Option A. Shubham, option A will be the right answer. All 1, 2, 3 are correct. In LPP, all the decision variables should be non-negative. That is one condition. And all the constraints must be converted into equation with no negative right hand side. If there is a negative RHS, then you should multiply the whole equation, whole constraint equation with -1. So sometimes we require a slack variable if the constraint inequality is having, if the constraint equality is having less than sign, then use slack variable. And if it is having greater than sign, then you use surplus variable. For an example, x1 plus x2 less than 5. So x1 plus x2 plus x3 is equal to 5. This is the slack variable. And if another constraint is x1 minus x2 greater than 2, x1 minus x2, then because it is greater than minus x4, that is surplus. But the right hand side must always be non-negative. 12, option A will be the correct. Next question 13 on the screen. A variable which has no physical meaning but is used to obtain an initial basic feasible solution to the linear programming problem is referred to as. If the constraint is x1 minus x2 greater than 2, then to convert it into equation, we will put x1 minus x2, minus x3 is equal to 2. Now to start the simplex method, this is surplus. To start the solution, we need to put a artificial slack variable, because there is no slack variable in this equation. So we will put an artificial slack variable. This is called as artificial slack. To start the solution, all the constraints should be associated with the slack variable, or we can call them the basic variables, the initial basic variable. So because the constraints inequality are having greater than sign, there is no slack variable, so we introduce the artificial slack variable. to start the solution. So that the variable which has no physical meaning as such, but is used to obtain an initial basic feasible solution to the linear programming problem is known as artificial slack variable. Option C is the correct answer for question number 13. Question number 14 on the screen, second last question. It is maximization problem subject to a plus b less than 10. 4a plus 6b less than 30, 2a plus b is less than 17, a and b greater than 0. Then what we can say about the solution? Look, what is the slope of objective function? The slope of objective function will be equal to minus 2 by 3, isn't it? Minus coefficient of a upon coefficient of b. What is the slope of this constraint? Will be equal to minus 4 by 6, that is equal to minus 2 by 3. If the slope of one constraint is equal to the slope of objective function, then there is a possibility it may contain optimum alternate solution. Option A will be the right answer. Question number 15 is again for the queuing model. I want you guys to solve it. On an average, there are 30 customers in a queue. What does that mean? LQ is given as 30. The length of the queue length is 30. If the arrival rate of the customer into the system is 16 customers per hour, that is lambda, that is 16 per hour. And on an average, 30 customers leave the system per hour. So the departure rate is 32 customers per hour. Then the average number of customers in the system, LS, will be how? Need to find out LS. And from how to solve it? Do you know the waiting time in the system is equal to waiting time in the queue plus service time? This is the general understanding. If we multiply by lambda ws plus lambda ws is equal to lambda wq plus lambda by mu. If we multiply from the Little's formula, it is ls. This is lq plus lambda by mu is rho. If you want to find out ls, then lq plus lq is given as 30 plus rho is lambda by mu, that is 16 by 32. Will give you the answer, that is 1 by 2. 30 plus 1 by 2, that is 30.5 is ls. B is the correct answer. For this, B is the right answer. Guys, that is all from my side for the day. So tomorrow at the same time, at 6 p.m. on the same platform, we will discuss the beautiful question from the forecasting as well as inventory. Again, very, very important topic of industrial engineering. So do join me tomorrow at 6 p.m. and do not forget to like this session, share this link to all your friends in your friend circle, and subscribe our BYJU'S YouTube channel so that you will be getting all the notification and updates for all the free sessions in this. All right, that is all from my side. Let me take your leave. See you tomorrow. Till then, enjoy, take care, have a good day, and stay safe, stay motivated. Thanks a lot, Jay.